What are we going to do to improve our overall wellness as a species, specifically in the United States?
The education, more broadening awareness of this and to put it forward as real science and get people to appreciate this relationship between their nutritional decisions and food choices and things like that and their metabolic well-being and hopefully end up with a more optimal health as a result.
Welcome to the Hope and Help podcast, where we talk about science and science-based tools for fatigue and chronic illness. I'm your host, Haylie Pomroy. I'm a #1 New York Times bestselling author of The Fast Metabolism Diet, a leading health and wellness expert. You guys, I'm back in school. I am currently getting my PhD in neuroimmunology. And as always, I am a fierce advocate for those in need of a little bit of help and hope. Today, we're going to talk about neuroinflammation, about COVID vaccines. And in order to have a really intelligent and broad conversation about this, I wanted to bring back an individual that you guys really loved his conversations in the past. It's Dr. Richard Deth. Dr. Deth is the Professor of Pharmacology at the Barry and Judy Silverman College of Pharmacy, Department of Pharmaceutical Sciences. Wow, that's a mouthful, at Nova Southeastern University. Dr. Deth, thank you so much for coming back. Everybody just really enjoyed our topic last time. And I wanted to dive a little bit deeper, especially with all the changes that are going on in this conversation.
My pleasure to be here with you, Haylie. Look forward to chatting with you today. And there's new things always to chat about.
Yeah, absolutely. I want to touch base. In our clinic, we are being inundated with individuals with long COVID. A lot of them have been, to the Yale Center and have had a lot of diagnostics. Maybe they've seen their docs. We're definitely not their first stop. But I wanted to just talk to you a little bit about what you're seeing in long COVID. Is there an inflammatory component? Like, what are you thinking is going on metabolically? What are we starting to see?
Sure. Let me make sure I preface my comments by saying I'm not a clinician. So, but I'm a laboratory guy, and the molecular aspects have my attention from the very beginning of COVID, when, like others, I was interested in what was causing the cytokine storm and what made people more vulnerable than others and so forth. And didn't take long before, obviously, the mechanisms of inflammation appeared and became obviously important. And delving into that, I got attention, and our lab got attention to the so-called inflammasomes. These are the structures that create inflammation. And the NLRP3 inflammasome, well, the one called NLRP3 inflammasome has been identified, especially in COVID, as really like a first responder to the viral infection, to the spike protein in particular. And when the NLRP3 inflammasome is activated, it causes the formation of the cytokines that cause the cytokine storm. And of course, in COVID, acute COVID, everybody was worried about such severe cytokine storm that it was life-threatening and potentially fatal, especially in a vulnerable subpopulation. It happened to be older individuals and diabetic individuals, for example, and obese individuals, just to add to that. But now we are thinking more about long COVID, as you brought up, and it's the same factors. But in the case of long COVID, it's my understanding from what I know of the literature, and now we're doing our own work in the lab on inflammation, that turning off or a failure to turn off inflammation is an important problem in chronic inflammatory conditions, because inflammation itself is a good thing.
If there were some good things that came out of the pandemic, I've always been a science nerd. I've always been into science, but I love that everybody became involved in science, right?
Correct.
People that had no desire or passion learned about cytokine storm?
It was a call to action.
It was a call to action.
Correct.
Absolutely.
And we each had different things to contribute. And because my work had been about the metabolic origins of autism, I particularly was thinking about the impending vaccination program, which was no doubt going to be launched more or less immediately when the pandemic got underway. And I was concerned about whether or not it would have any consequences, negative consequences, for individuals. And so that's why I started to focus on it. So that's what I can contribute, because that's what my knowledge base is.
And so when you saw COVID coming, or when we started having it prevalent in the United States, you were, I guess I would say, preemptively going, okay, down the pike is going to come a vaccine fairly rapid.
Sure.
And with that, so as we're watching this, I want to say, like, acute inflammatory response that's supposed to happen, right? When we get a cold or flu or a novel virus, we're supposed to have this big immune blast.
We're glad to have it.
Okay.
Because it serves our purposes. It's part of our innate immune response that eventually gives way to the acquired responses associated with antibody production and so forth. But it was important to me to learn what I could about that.
And then some of what's happening is that first charge of reactivity is becoming now chronic.
Yes, it's what we now appreciate, and mechanistically I would love to dive into it as deep as you'll tolerate, is that there's certain metabolic conditions that turn on inflammation, and nature uses those to turn on inflammation when you have a viral infection or other provocative events. But then it needs to be turned off. And you have some autoregulatory mechanisms to turn off inflammation. And if they don't work, you're left with a chronic inflammation. And this is, I think, what COVID represents in many cases.
Hey guys, it's Haylie Pomroy, your host. Right about now, you're probably struggling to achieve the health that you deserve, and you're just not sure what you need to do in order to get it. So what I've done is I've created a special link for you that will give you the nutrition and supplement programs that I use in my private practice to achieve amazing results for my clients and my community. Go to HayliePomroy.com/podcast. Plus, when you use that link, you'll get a 20% discount just because I love you. Again, that's HayliePomroy.com/podcast. Now, back to the episode.
When I was in Ljubljana this year, I went for the International Conference of Autoimmune Disorders. And a lot of the presenters, from Turkey, from Israel, from Germany, Istanbul, like all over the world, you use the word, a provocative event. And there was a lot of conversation about individuals with long COVID that spike protein or the initial immune response was a potential provocative event. But there was also, and they were really on the adjuvant in the vaccine, right? That was also could be a provocative event.
Correct.
And can you explain to us a little bit? First of all, my question is, was it a vaccine or an inoculation? And are they different?
Well, they're in the sort of lay parlance, they're the same. But the vaccination aspects of it, as we understood it, can be, especially in case of the RNA virus, viral RNA, spike protein RNA, wasn't actually an inoculation. There was no inactive bacteria or dead bacteria or anything like that. It was really a vaccination, in this case, a technically defined vaccination. And so clearly not an inoculation. And we can go back to Edward Jenner and some of the very first people on the vaccination smallpox scene. And, that was an inoculation. But we've moved on. And I think looking forward, I think there's a fair question about how will vaccination in the future look? Have we made the jump? will vaccinations in the future be distant from inoculations? Will they be like the spike protein-based mRNA vaccines that we've seen here?
The purpose of an adjuvant, sometimes in a vaccine, if I understand it correctly, is as a preservative, but there's also another aspect where it's designed to impact the immune system so that it has a more, the altruistic term I've heard is a more beneficial, the vaccine is stronger without making it stronger. Is that right?
If the vaccine would be stronger in its immune response, antibody production, in proportion to the amount of the antigenic material being the same. If you add an adjuvant, then you get more bang for your buck, if you will, when you have that. However, the adjuvant itself has to be considered. And of course, with aluminum, its persistence and the fact that we can't convert it to an innocuous substance, that the aluminum will always be aluminum as opposed to some other metabolic destruction mechanism, makes the aluminum subject to certain concerns. I have those concerns, that its adjuvancy and its oxidative stress promoting activity can be problematic. It's not a short-term adjuvant. If you had an adjuvant that worked today and worked in the next 2 days or 3 days and then disappeared or otherwise was benign after that, but that doesn't fit aluminum.
When I was traveling, when I was at the international conference, so many of the countries had defined what they called Asia syndrome, which was adjuvant-caused autoimmune disorders.
Correct.
And it was so common and non-controversial to have this really intelligent scientific conversation. I felt like I was on a different planet,
yes.
Quite frankly.
Yes, I understand that, and you're exactly right. We shouldn't sweep away the consequences of these things that stimulate the immune system. Right. And you only have to multiply that times the number of vaccines, both aluminum-containing and non-aluminum containing, to appreciate that the effects that the adjuvants have to be considered in the overall risk-benefit calculation.
Right. And so with long COVID, with individuals that are dealing with chronic dysmodulation of the immune system, with chronic inflammatory components, some clotting components, we're seeing so many different things show up from a clinical perspective. Did we predict or expect that people that had the natural exposure to COVID versus the vaccination of COVID, to see those populations expressed differently? Clinically, we're seeing a lot of similarities.
Well, there are bound to be similarities because the stimulus is overlapping, at least, whether it's the intact virus, in which case the various components could be the antigens that are the basis for the immune response. But the vaccination then selects out one of them and says, for spike protein in particular, that will be the antigen of choice for that. And it's not a bad choice because, of course, it's the most highly exposed and functionally important protein in the virus. So no doubt there'll be differences. The natural exposure, of course, there's no concerns exactly about the mRNA being reverse transcribed and incorporated into our DNA, which could happen because any particle, any virus that comes into your body and produces mRNA, could do that as a sort of a memory of their infection.
Is that like in an IgG, like in an immunoglobulin form, or is it actually in the structure?
Well, personally, what I was thinking of is the fact that there are reverse transcriptases, enzymes that can start with RNA and mRNA, for example, and can convert that back into, incorporate that into DNA. They can take the same sequence and convert it back into DNA and reinsert that newly formed reverse transcribed DNA into our own genome.
Dr. Deth, one of the things that you do so well for me is you talk to me in pencils and crayons sometimes. I always say pencils and crayons, Dr. Deth.
Okay.
So take that concept and help me digest what that means. So it means that this particular virus could become part of us like the other 8% maybe, or
nature has built into our genome, our genes, this mechanism for reverse transcription. And we see that very dramatically when we look at the overall composition of our genome, our DNA, where vast amounts of it don't code for proteins or active genes as we think of them, but they are, for example, retrotransposons. That is, whole segment, large majority of our DNA is actually composed of things like there's one called line 1, for example, that some people call junk DNA. But in any case, the line 1 mechanism makes available these enzymes that can take RNA and convert it into DNA and incorporate that into our genomes. And it's been demonstrated to occur for spike protein in particular. It wasn't a surprise that it happens, and it doesn't mean that it's a totally bad thing, because it gives our genomes a look back to say, okay, what kind of exposures did we have in the past, and presumably educates our genomic composition and gives it some history that way. In any case, that can be, therefore, I guess nature didn't make a mistake. I guess it's a good thing. But it is a point of concern, because when it gets reinserted back into your genome after being reverse transcribed, it's sort of a random insertion. Where it's going to go could create a problem or not.
Or not. Yeah.
It's kind of random.
So I know, like in autism, and I'd love to talk some in that aspect of it. We talk about sometimes there being a provocative event, that there can be, can there be a predisposition from a familial perspective, from a genetic perspective, but there can be something provocative. And that's what we're thinking in the long COVID space, right? Is that the body had a provocative event, and that provocative event could have been either the vaccination, it could have been the native infection. So are we taking some of the autism science and applying it into the long COVID science?
Exactly that, Haylie. And I've often thought of this as a gift from autism, from the child, that gives a gift to the adults and or the rest of the world, as long as we learn from it. If we don't learn from autism, then that's something, a loss on our part. And of course, we want to solve the question of where does autism come from in general, but there's a particular importance here and a particular relevance, as you said, to COVID and other fatiguing illnesses. When we appreciate what's special about autism. And what we know for sure is that autism is a metabolic disorder. It's a manifestation of metabolic abnormalities or that involve the oxidative and antioxidative metabolic pathways in autism. And in particular, they have low levels of the antioxidants that are needed when you carry out aerobic metabolism. They have kids with autism, and this has been found by 100 studies, and no studies have found the opposite or disagreed with it. So this is a bona fide feature of autism. Too little antioxidant, in particular the sulfur compound called glutathione. And if those levels are, as they are in autism, about 1/3 less than normal, then they result in a condition of oxidative stress, where there's an imbalance in terms of the demand for antioxidant and the supply, which in autism is too low. So that oxidative stress then plays out in different ways. Our earlier work focused on the epigenetic consequences of oxidative stress, because oxidative stress impairs methylation, and that can have epigenetic consequences during development, neurodevelopment. But then now more recently, we appreciate that oxidative stress is also a trigger for inflammation.
My name is Jimmy Orocho. I am a veteran of the 1990-1991 Persian Gulf War, Desert Shield, Desert Storm. I work for Dr. Nancy Klimas at the Institute for Neuro-Immune Medicine in Nova Southeastern University. We are in Davie, Florida. We are Gulf War illness clinical researchers in the need for research participants. By participating, you will help yourself and your fellow veterans, contributing to the discovery of the cause of Gulf War illness and how to best treat the illness. Our telephone number, 954-262-2870. Our email, QuickTick, Golf Whiskey India Charlie Tango India Charlie @nova.edu. We do also decentralized clinical trials. That means that you may be able to participate in this research from your hometown. Thank you very much.
With an individual that has a compromised lower ability to produce glutathione or metabolize glutathione?
It's actually an inability to produce it. It's, again, glutathione is a simple tripeptide, that triamino acid, 3-amino acid peptide, in which the key part is the amino acid cysteine. And if you don't have enough available cysteine, then in fact you have decreased levels of the glutathione. And so it's really underneath it as you dig down and peel that onion and look a little further deeper. It's a problem with too little cysteine, and kids with autism indeed have about 20% lower cysteine, and that translates into about a 35% lower level of the glutathione. And so this is the vulnerable group.
So in both of those, with cysteine and glutathione, those need to be at optimal level to deal with toxins in our body, correct?
Not only toxins, it's the every minute, every second, every millisecond demand for antioxidant that arises from mitochondrial activity. We use mitochondrial-derived ATP as the universal energy source of the money that keeps cells going and doing their things. And the brain uses oxygen at about 15-fold higher rate than other tissues do to make ATP and as an energy source. So the brain, with such a high aerobic metabolism, is going to be the most vulnerable to having a problem with the byproducts of that mitochondrial aerobic metabolism, the reactive oxygen species. And that's where you need moment to moment, minute to minute, you need enough antioxidant to reverse or to neutralize the mitochondrial produced reactive oxygen species.
So you would agree with me that we have higher statistical rates of autism?
Okay, we do. I think it's 1 in 36-ish at the moment, and certainly even higher for males than females.
And why? I know that there's not one cause, but do you think there are contributing factors in our environment? I mean, me in food, in our neurotoxic exposure. What's going on?
A lot of things are contributing, no doubt, to that. For example, high fructose as a source of sugars. The fructose doesn't generate antioxidant NADPH because the fructose is different than the glucose, let's say, would be otherwise in regular cane sugar, for example. And then we have BPA, bisphenol A, which we can recognize as industrial product that has showed up in autism studies as a factor in contributing to the autism cause. So we have food, we have toxic exposures, pesticides, herbicides, and all of them are toxic. Almost everything that's called a toxic is because it lowers your glutathione and your antioxidant capacity. That's what makes most things toxic. So again, if you have all of those things combined, then certain people, especially if they have perhaps a genetic or let's call it a familial trait of having marginal levels to start with, then when they are exposed to all these factors, then in fact they'll fall below a critical threshold for, let's say, normal or adequate antioxidant activity, and they'll have oxidative stress. Now we can add inflammation to that. We can appreciate that this inflammasome that I referenced earlier, the NLRP3, it's actually built to be a metabolic sensor. That's what we've learned in the last year or year and a half or so, is that this NLRP3 inflammasome is turned on by oxidative stress itself. And it's also turned on, interestingly, by palmitic acid, a fatty acid, C16 palmitic acid, and as well as being turned on by viruses, spike protein, and uric acid, the usual things that cause inflammation. And so it's a sensor of your metabolic well-being. And you can turn on inflammation with no bacteria, no viral things. This is what you could call this sterile inflammation, for example. It's really now metabolically induced inflammation. And it's more likely to occur with age. As you get older, we see all these itis disorders as we get older, and it's quite logical because your vulnerability to oxidative stress goes up with age, and your glutathione status is more compromised with age. It's a part of the aging process. So inflammation probability or disorders are more common with aging.
But we're seeing so many kids sick, and we're seeing so many young, and my children are in their 20s, right?
Mm-hmm.
And sitting around the kitchen table, their friends in town. We recently had a wedding event, and I could not believe the itises and the conditions and the chronic diagnoses that these 20-year-olds are getting. I want to take a step from your perspective in the lab, and I love it from a pharmacology perspective as well. How are we going to change the health of our population?
Well, I think we do have to have clarity about the importance of these things. First of all, you have to recognize what we should address. What is it about our metabolism as it leads to or promotes health, hopefully, that we need to work on? And then you can talk about how to work on it now that you've focused on the target in a certain way. And from what I've outlined here and from our own work, and I'll admit to being a little myopic, a little self-centered here in terms of my perspective, we focused on these antioxidants and the sulfur amino acids that are essential in the diet for adequate antioxidant levels. Cysteine, let's focus on it rather directly here. And where do we get that from? Like everything else, we do get it from our diet. And we have to extract it from the diet and absorb it into the body efficiently so that we have enough of that raw material to make antioxidant.
So I just want to say one of the things, because I love what you just said about that, is, I'm a big advocate for eating. I don't think fasting should be have any place in the nutrition conversation. Every single thing that you've talked about, whether it's turning on those enzymes, whether it's modeling or building an inflammasome, whether it's detoxing aluminum, whether it's isolating cysteine, reducing glutathione, sodium oxide dismutase, we go on and on. Everything that happens metabolically is nutrient dependent. And healing a body is extremely nutrient dependent. And reversing antioxidant damage is extremely nutrient dependent.
It is. We'd have, let's face it, what other modalities are there? We're made from nutrients and from what we eat. Some cases, that's not a good thing.
And we're remodeled from nutrients.
Unfortunately, we can remodel. Many processes, most, I would say, are reversible. And we're learning more about them here. And we can appreciate why, and in more detail, the recommendations of nutrition play out the way they do. An important one, you mentioned young people having more disorders that might be linked to inflammation. And I'll second that with the idea that gluten and casein and removal of those things from the diet help some people, a fair number of people. And again, we discovered, and I'll take credit for that gluten and casein interfere with the absorption of cysteine. So as a result of that, we can see where a diet that restricts the gluten and lowers the casein, except for the A2 milk casein, I might add, can be health promoting because it'll help you have enough antioxidant to suppress inflammation.
As I'm pulling together, nutrition prescriptions for people, and I talk about, if an individual has, a reduced mitochondrial metabolism, their metabolism is, slow or sluggish. There are certain things that I pull out when we're working on the healing process. And it's not that I pull gluten out because it became a trendy thing to do, but I read so much of the research that you did about it significantly suppressing the cysteine and the body's ability to produce glutathione, which is critical for cell respiration, for the reduction of inflammation. And so pulling it out is not, so I tell people when you go to a restaurant or you ask, or you make or you create gluten-free, which traveling internationally is so easy, right? But we've also glutenized a lot of our product in the United States. We've also hybridized and genetically modified a lot of our grains so that the gluten is more difficult to break down and can even cause more suppression in cysteine. I mean, it's not like a trendy thing to do. It's for me, it was a requirement for healing my inability to produce, and I had a significant reduction in glutathione and sodium oxide dismutase, and I'm homozygous MTFHR. Good luck, right?
Well, yeah, okay, that's a potentially dangerous combination.
And it was. I was on 60 to 80 milligrams of prednisone. I oscillated between Inurin and Celsep and Mepron. But you know what that gave me? That gave me hospitalization and I was losing my right kidney.
Yeah, you can't. When you have nutritional issues, can't be solved by pharma.
Thank you. Oh my goodness, I love what you just said. And everything's a nutritional issue because we're nutrient dependent.
That's who we are. We're made of these things. They're natural, and their properties cannot be replicated by chemically synthesized alternatives, even though drugs do have their place. I'm a pharmacologist, so I understand that, but it's really not to replace the important role of nutrition, where you can accomplish so much by making good nutritional prescriptions, the way you described it, or certainly nutritional decisions. And I think that that's been sort of tamped down as how we get to be healthy. You get to be healthy with nutrition. If you're sick, then you should think about improving your nutrition first. And then pharma is always there lurking in the background. But in fact, really the first and the least toxic thing, because we don't worry about the side effects to the same way we need to worry about the side effects of drug approaches here.
Even from a pharmacological perspective, and I talked about this with a lot of my docs in the clinic, is in order to swallow, get into the bloodstream, metabolize that drug, that's nutrient dependent. And so even to take a pharmacological approach should be for the ideal outcome of the drug. It should be married with a strong nutritional approach because there's that requirement metabolically, everything we do is nutrient dependent.
You have to take care of your innate metabolic systems. They have to be as close to normal or homeostatic as they can be. And even in that setting, you'll probably optimize the benefits of the drug therapy under those conditions and decrease the side effect potential from those same drugs. The drugs that need to be metabolized but can't be metabolized because you have low glutathione levels, going to increase the chances of adverse drug effects from prolonged duration of the drug actions beyond what's normally planned for.
Dr. Deth, I really appreciate it. I want you to just leave us with some hope, right? For the future of our health. What you're seeing in the lab, talk to me what are we going to do to improve our overall wellness as a species, specifically in the United States?
One of the things that I think is tragic is the fact that our doctors, MDs, DOs, or whoever, don't understand these metabolic factors and their relationship to diseases as a part of their education, and they should. And it's not anti-anything to put that in. It's not anti-pharma. There's, again, a synergy between the goals of those approaches. So in any case, I think bringing this into the educational realm for the appropriate health professionals, which MDs and DOs, for example, be one of those, but there are others as well. I'm in pharmacy, and so I would actually like to see pharmacists be more cognizant of this as well, especially since they typically look out of their pharmacy across the aisles of supplements and are in a physical position to actually help people to find their best life that way, I think.
Right.
So in any case, the education, more broadening awareness of this and to put it forward as real science and get people to appreciate this relationship between their nutritional decisions and food choices and things like that, and their metabolic well-being, and hopefully end up with a more optimal health as a result.
I love that. And I really hope, like I said, out of the pandemic, I do feel that the gift, and you talked about the gift that the children of autism have given us from not being able to deny what's going on metabolically in the tissue and in the brain, and the gift of the pandemic, having people learn about their immune system. I mean, people talking about T cells and B cells and cytokines and spike proteins. It makes me so happy because it's what's going on within us. And I do feel like with what has happened, recently politically, no matter what side you land on, just that there's conversation happening about the impact, how we are impacted by what we put in our bodies. We are the filter, right? And I always say, if you're in a room and there's smoke, you either are the filter or you buy a filter, right?
We need to understand ourselves. And in this case, these particular metabolic aspects of who we are, how we work, and how we can connect these to everyday conditions. We talked about long COVID, and now we can understand long COVID and in the terms that apply to metabolism and antioxidant status.
Well, I love that you said that, and please, Dr. Deth, I would love to have you come back. I want to encourage our community, and you just gave us a lot of permission to really learn how to understand ourselves. And I hope that from a political aspect, from a pandemic aspect, from a science aspect, from an educational aspect, that it all comes down to really understanding what's going on within our body and really listening when our bodies are struggling. I really thank you so much for being here. Please come back.
Of course I will, Haylie, and thanks for having me today.
Absolutely.